Welcome everyone. In this video lecture, we will solve a problem based on diode, which is from Microelectronics circuit book. So the question is, the circuit shown below can function as a logic gates. So these two circuits, basically these two circuits are just the equivalent of this one. Instead of this current source, we have made some resistance with some VDD. So these two circuits, so basically two circuits are there. This was a single, say figure one. Say I can say figure one. I am saying this one is a figure 2. Okay, two circuits are there. Okay, and both represent some logic gate. Okay, for input voltage are either high or zero, high or low. We can say one denote the logic high and you denote the logic low. Okay, prepare a table with 4 columns including all possible combination and the resulting value of the x and y. So there are two inputs A and B. Okay, here the same circuit A and B. Also AB. AB is the input, and the resultant output is X and Y. So we have to prepare a table with 4 columns. Okay, including all possible combination. So what we have to do? We have to make a column like this X and Y. Okay, X and Y. Okay. Okay. So what we have to do? We have to prepare a table with 4 columns including all possible combination, okay, of a and b and the resulting value of x and y. So that's why we have making x and y. What logic function is x of a and b? So what is the this one logic circuit? What logic circuit what logic function of y? Okay, y gives what kind of logic function? For what value of a and b do x and y have same value, and for what value of a and b do x and y have different opposite value? Okay, so the possible combination we can say for a and b are either 0 0, very simple question, but 0 1 1 0 and 1 1. Okay, so now what we can do? So there are 4 combination. So 0 represent logic low value. Okay, and 1 represent logic high. Okay, means low value of signal, high value of signal. Okay, so for the very first thing, when we are saying, when we are giving a and b as a 0, okay, and all the diodes are say ideal diodes, a and b are 0. Okay, so these two are forward bias when a and b are 0. Okay, here I am writing a and b are having logic 0. We are giving 0 input. Okay, low input, we can say low input. Okay, for the low input, both d1 d2 and d2 on. Okay, or short circuited. Okay, very simple thing, short circuited. So it means that this one is somehow just make a short circuited. Okay, this one is short circuited. Okay, so when it is 0 and 0, okay, or any 0, okay, the 0 volt will come here, appear across the x point. So we can say that this one will be 0. Okay, the same voltage will appear because the ideal diode. Okay, now 0 and 1, in the case of, now first we are discussing about this circuit. Okay, now for the 0 1 means what we can say, when 0 0 it should be 0. Now when a is, okay, when a is 0 and b is 1, okay, means logic 0 logic high, logic low logic high. So in case of 0, d1 will be on and b is 1, so it is the reverse bias. Okay, so d2 will be off, simple forward bias. okay, and this one is reverse bias. Okay, so D2 will be open. Okay, so when I'm just, so in this case the circuit will be just A will be sorted. Okay, for the B it is open circuited, or somehow like this. Okay, so again this A value output will be come, okay, appear against 0. So A will be 0. Okay, so A will appear across this point, so this value will be automatically 0. Okay, means here in this case when it is 0, again it is sorted. Okay, when it is 0, it is again sorted. Okay, so this 0 will come here. Okay, in this one 0, again 0, it will open circuited, open circuited. Okay, this was just a representation point, representation how I am representing the now in the third case 1 0. In 1 0 case I am writing when A is say 1 and B is 0. Okay, so A is 1 means high value, so D1 will be off and D2 will be on. Okay, means simply what we can say, this one will be open for A is equal to 1 and for B is equal to 0. This one is the circuit. Okay, but again this value will be come here. I am not making the other part of circuit. Okay, so this will come again X as a 0, so this value will be again 0. Okay, in this case 1 0. Okay, not a issue, it should be 0. Okay, now in the third case, in the final case, sorry, in the final case 1 1. In case of 1 1, A1 B1 both are high. Okay, so both will be open circuited. Okay, both will be open circuited, A1 B1. Okay, and there will be current. Okay, and this is somehow open kind of thing. Okay, clear? So this will be open. Okay, so now this will be open, so there will be current will be almost 0, because this one is open, there is no path for the current. So the potential of this value will be also same value, means VDD if I saying, so it should be also high value, high, high or logic high value. Okay, so the X value will be always be the 1 value. Okay, means these two are open circuited. In this case we can say, okay, for the blue representation I am just showing. Okay, for the, for this one 1 and 0, this one is open. Okay, and this one will be sorted. Okay, for the another one what we have observed that this will be again open. Okay, for this condition 1 1 condition. Okay, this one is also 1 1. Okay, so no path, so I will be 0. So I will be 0 means this potential will be having the same potential edge of date of VDD, because if some resistors, this value is VDD, this point is also high R, so the current will be 0 0, because I equals to higher potential, say this potential at point 1 and 2. So V1 V2 I am saying, so V1 minus V2 by R, both having the same potential VDD minus VDD by R, so it should be 0. Okay, so 0, so it should be like this. So this represent X is nothing but simply our a AND gate, because in the AND gate, so this one is nothing but simply a, okay, A and B, and this X is A and B. Okay, this one is our, okay, X equals to A and B. So this is X is nothing but simply A into B, or that's why we are saying this one is a AND gate. So this is a logic AND gate. Okay, simple representation, everything. In the AB1 both are open, so the same potential will be there, so current will be 0, the circuit will be open, so this one is the case. Okay, for the first figure now we have explained. Now for the second one, for this figure. Okay, So this one is again we have to take both will be 0. One A and B are 0. Here I am writing. Okay, I am just making a column here. Okay, okay. This side I will write for this when A equals to B equals to 0. Okay, so these two is just open circuited. Say D3, D4 will be off, or simply say open, open. Okay, so this D3 will be like this. D3, D4 will be what? Open. Okay, so the current will be almost zero. So if it is zero potential, so it should must be zero potential, so there will be no current in the circuit. So this one is here, it is connected to ground, so this one will be also zero. It's very simple, so this should be our zero value. Okay, very simple. Okay, now A is 0, B is 1. So B is 1. Okay, I am selecting some different color. A equals to 0, B is 1. So A 0 again it is open circuited. Okay, again it is open circuited. B is 1, B is 1 means this one will be short circuited. So B is 1, so directly this one will come here. Okay, directly, so this should be 1. Again for different A1, B0. A1 means A1, this one is 1, so it should be our sorted. Okay, and this should be open. Okay, should be open. So this A value, 1 value will come directly to here. So simply one can write 1. Now both are 1. So both are 1 means A and B 1. Okay, both D3, D4 forward bias. Okay, short circuited, short circuited. Okay, so both will be 1. So it should be simply our 1. Okay, and 1. So now this is nothing but simply our OR gate. A, B, and this one Y. So Y equals to A plus B. So this kind of representation is our OR gate. Okay, and this one is our AND gate. Okay, gate non right, AND gate. Okay, so in the question they are just asking what logic function is X. So X is our A dot B. Okay, Y is our A plus B, means this one is OR gate, and this one is our AND gate. Okay, I am just highlighting. Okay, this one is our X is our, and this Y is our OR gate. Okay, very simple. OR gate, Y is our OR gate, this one is our OR gate. Okay, and this one is our AND gate. Okay, okay, I'm already written here this one. Okay, and for this one, this is this two table is for AND gate, AND gate. Okay, this yellow one is our AND gate. Clear? Now, so possible what are the logic function X? So X is our AND gate, X is our, okay, once again, X is of AB AND gate, this one is our OR gate. What value of A and B do X and Y have the same value? X and Y have the same value for common value of 1 1 and 0 0. Okay, when A and B are same, the X and Y value are same. When A and B are different, it have different value. Okay, so once again, for what value of, okay, for what value of A and B, okay, having the same value. Okay, and for what value of have opposite value. Okay, so once again I am writing. I am taking a lot of time, but it is very necessary to discuss step by step. This one is AND gate that we have covered. This one is our OR gate. Okay. For A and B having the same value for common input 0 1 0 0 and 1 1, and this one different value for 0 1 and 1 0. Okay, so this is all about this question. So this is the problem from a microelectronics address with book. So thank you for watching this video.